In the 18th century, around 1735, you get the invention of the octant. And this is a very early octant. It's actually divided scale with an unusual method you may have never seen called transversals. It measures to 2 minutes of arc. What it does is by sighting through this little pinhole sight at, say, the horizon through this half-silvered mirror, and then moving the index arm, what it does is the star, let's say, that I'm looking like the North Star, I take its reflection off this mirror down to the mirror I'm looking at through here, like this, and when I line up the horizon and the reflection of that star, I then can, off the scale here, read the angular distance. The great thing about this is, on a rocking ship, the images are very stable together because of this mirrored arrangement, unlike with the cross staff or the other instruments you're using. So this is an early octant, and immediately becomes widely used at sea. So I brought a number of navigational instruments, and I'll start with this. This is an octant. It's made about 1800, and it's made of wood and has an ivory scale here with a vernier. And my favorite part about octants of this period is they often come with this handy little pencil that sits in here, comes out. And so you make your observation, and then you say, oh, okay, that's 23.5 degrees. And then on the back here, you have this handy little pad made of ivory where you scribble down your observation. Because on a deck of a ship where it's windy and wet, and you're not going to have a paper lying around, it's handy. The octant only measures up to like 90 degrees. But it is an eighth, because of the mirror, you take an eighth of a circle. That's where it gets the name the octant. But you can, on that arc, you can divide it to 90 degrees. But for lunar distances, you want bigger angles, like up to 120 degrees. So they invent the sextant, which is the same thing, but better made. And this is like a sextant. This actually is a quintant. It's a fifth of a circle. The difference is here, you'll see, instead of wood, it's brass. It's very structurally rigid. It has a handle. It has, instead of a wooden scale or an ivory scale, it has a silvered scale. You can divide it more finely. It's inlaid on brass. Have a reading microscope, so you can read it. You have a thing called a vernier, which allows you to read fractions of degrees. Instead of a pinhole sight, you have a telescopic sight, which improves what you can see. That screws in there, and you have a choice of telescopes that are in this box. And otherwise, it works the same way.
So can you just show us, like, if we pretend that over there, over David's head, is a star that you're looking at, can you just sort of show us what you would be doing?
So what I would be doing is I'd move these filters out of the way if I didn't need them, and I would sight the star, and I would move the index arm until I would get a reflection of the star from this mirror onto this half-silvered horizon mirror while I was sighting the
so you're trying
horizon.
to measure the angle.
And then when I got those to line up, I would read the angle of separation here. So I could also use it in any orientation and measure the angle between anything.
Right. But usually it would be for the angle of elevation of the star off the horizon.
Well, if I wanted to find latitude,
right,
that would be how I would do it. If I'm finding, if I wanted to find longitude, I would be measuring the angular separation between a star and the moon, a lunar distance, and then using that information to calculate my longitude. Now, this is expensive because it's, I mean, all the differences in material and construction. So, so you'll find even into the 19th century, a lot of people are still using octants instead of sextants, unless you're really going on a voyage that is more critical and you can afford a sextant. If you're on a whaling ship, an octant would do to go across the world and back. If you're going coastal navigation, say shipping things from Philadelphia to Boston and back, or up to Maine, an octant is fine for finding latitude. And it's good. You could use it for a lot of longitude things. At just certain angles, you would want the sextant.